Hello my dear friends, welcome back to our YouTube channel. This is your ADC Max. There are many techniques to determine the inverse Z transforms. This is the one among the technique to find the inverse Z transforms by using long division method or power series method. Some of the other methods are called convolution theorem, residual method and method of partial fractions. Please go and watch. I made separate videos how to find the inverse Z transform by using convolution theorem, method of partial fraction as well as the residual theorem. Please go and watch it. Yeah, it's coming back to this method. How to determine the inverse Z transform by using the long division method. Already we know long division method in the lower classes, and is often called as power series method. Yeah, let's see that. So what's actual idea? The idea is very simple. Already we know that the Z transform of x of n. What is Z transform of x of n? Is nothing but sigma n equal to 0 to infinity x of n z power minus n, or is called x of z. So here very simple concept is you expand this x of z in the proper power series method, in the proper infinite series, power series. Power series means it's increasing power, monotonic increasing. Z power minus n is a power. So z power minus 1, 0, z power minus 1, z power minus 2, z power minus 3, z power minus 4. So we can express into this model as a power series model. That's why it's called a power series model. How to get this power series? We can do the long division method, the usual division method. From that we can collect the coefficients of z power minus n. We can collect the coefficient of z power minus n automatically, which will give the required Z transform of x of z, that is equal to x of n. So that is a simple concept. Once I repeat this, from the definition x of z nothing but n equal to 0 to infinity x of n z power minus n. Let us expand this in the power series method, z power minus n, that is z power minus 0, z power minus 1, z power minus 2, z power minus 3, z power minus 4, by doing the division method, long division method, and collect the coefficients of z power minus n, which will give the required z transform of x of z, that is x of n. But when we get the nth term, let us use some basic concept like arithmetic progression, some geometric progression concept. Let us see the problem number 1. How to find the z inverse of, see the question number 1. Determine the z inverse of 10z by z minus 1 into z minus 2. So this is the given question by using the long division method, is often called as power series method. Let us see how. I want to rewrite this by z power minus n. So that's very important. The very important step is here to rewrite the given term into the power minus 1. So what we are going to write, which is minus 1. In the denominator is a product of two linear factors. So minus 1 minus 2 minus 3. Minus 1 into minus 2 is plus 2. So this comes as z squared minus 3z plus 2. Is right? Our ultimate aim is to determine the x of n, but we will collect the coefficient of the negative powers of z. So when we get the negative powers of z, very simple concept. So can we divide z squared by the numerator denominator? Can we divide z squared by the numerator denominator? Because z squared, okay, otherwise we can take z squared outside here, we can bring to the numerator. So whatever it is. So when you divide z squared, the numerator as well as denominator, otherwise you can take z squared from the denominator outside. Let us bring push the z squared in the numerator. So what will happen? So this becomes z inverse of 10 z power minus 1. Correct, sir? Because of z by z squared is z power minus 1. Now the denominator becomes 1 minus, because z squared by z squared is 1, minus 3z by z squared is 3 by z, otherwise 3 z power minus 1, and 2 by z squared is 2 to the power z power minus 2. So let us rewrite this into this minus power, that is the negative powers of z. This is the very first step. So now once we got this one, then the rest of the thing is very simple. What is the very simple the case? What's the method is called long division method. So I want to divide this by this, that's it. I want to divide this by this. Very simple concept. Can I divide this one? Yeah. So the first one is the numerator term is 10 to the power minus 1. I'm going to divide this by 1 minus 3 z power minus 1 plus 2 z power minus 2. So you know the usual division, the same idea only. I want to cancel this term. When we get the cancellation of this term, I want to generate this one. So very simple concept. Whatever we have the first term, We divide this by the first term of the divisor, 1. So 10 z power minus 1 by 1 is 10 z power minus 1. Now multiply this 10 z power minus 1 with this each and every terms. What happened? It will generate 3 terms. So 10 into 1 is 10 z power minus 1. 10 into minus 3 minus 30 z power minus 2. You see that it is increasing. The power series it is increasing. Minus 1, minus 2, minus 3, minus 4. And what about 10 into 2? 20. So 20 z power minus 1 into z power minus 2 is z power minus 3. Now let us change the sign. Minus sign plus becomes minus. So this can be cancelled. Now this will comes here. 30 z power minus 2 minus 20 z power minus 3. Once again, what is the perfect divisor of this term? Yeah, 30 z power minus 2 by 1. So this plus 30 z power minus 2. Now multiply this term to each and every terms of the divisor. What will get? 30 z power minus 2 into 1 is 30 z power minus 2. 30 z power minus 2 into minus 3 minus 90 z power minus 4, because minus 2 minus 1. I think so. Minus 2 minus 1 minus 3. Yes. 30 into 2 is 60. So 60 z power minus 2 z power minus 2 z power minus 4. So you see that it is going increasing order. That's called the power series, monotonically power increasing series. That is the negative powers of it. Power minus 1, minus 2, minus 3, minus 4. Actually it's called the decreasing function, right? Now can you change that minus sign? This becomes plus, this becomes minus. This will cancel. So plus 90 minus 20 is plus 70 z power minus 3. And this is minus 60 z power minus 4. Right? Is right? Now once again continue like this. So 70 z power minus 3. So 70 by 1 is 70. So plus 70 z power minus 3. Multiply the 70 z power minus 3 into 1. We get 70 z power minus 3. 70 into minus 3 minus 210 z power minus 4. 70 into plus 2 plus 140 z power minus 5, etc. etc. Now change the sign. Minus, this becomes plus, this becomes minus. Now 70 is going to be cancelled. Plus 210 minus 60, it is 150 z power minus 4. That is minus 140 z power minus 5. Can you guess what is the next term? The next term is probably this 150 z power 4. Yeah, plus 150 z power minus 4. So it is going like that. It is going like that. It is connected like that up to infinity. Yeah. But once we get your certain 3 to 4 terms, we can easily stop the procedure. From that we can generalize. We get the required x of n. So that is a concept. Now see that this is the given input. We can divide this by long division method. It will generate the proper power series. But actually what is the Z transform of x of n? Is something but sigma n is equal to 0 to infinity x of n into z power minus n. So this is equal to now, what is this? 10 z power minus 1. Yeah, putting n equal to 0, what will get? Putting n equal to 0, we get x of 0. So x of 0 into z power minus 0. Putting n equal to 1, we get this x of 1 z power minus 1. Putting x equal to 2, we get x of 2 z power minus 2. Substitute x equal to 3, we get x of 3 z power minus 3. So continue like that. But this is equal to the quotient. What's the quotient? 10 z power minus 1 plus 30 z power minus 2 plus 70 z power minus 3 plus 150 z power minus 4. Now equating or comparing like coefficients, what do we get? Comparing like coefficients. Comparing like coefficients. So what happened? When I compare this one, I think so x of 0 is equal to 0. Right, sir? Because there is no z power 0 here. X of 0 is 0. What about x of 1? X of 1 is 10. Right? X of 1, 10. X of 1. What about x of 2? X of 2 is equal to x of 2 here, x of 2. Coefficient of z power minus 2. What about the coefficient of x power minus 3? There is z power minus 3. 70. So this x of 3 is 70. What about the coefficient z power 4? Probably is x of 4. So x of 4 is 150. So continue like that. So from this, for n equal to 0, this will come. For n equal to 1, this will come. N equal to 2, n equal to 3, n equal to 4. You are right. I want to generalize this one to get the x of n. That's a very simple concept. So n equal to 0, so 0 no need to bother about. When n is equal to 1 is equal to 10. N equal to 30. 30 can minus 10 into 3. Otherwise 10 into 2 squared minus 1. Right? This 10 can minus 10 into 2 to the power 1 minus 1. What is 2 power 1? 2, 2 minus 1, 1, 1 into 10, 10. Right? That is 2 squared is 4, 4 minus 1 is 3, 3 into 10 is 30. When n equal to 3, what happened? This becomes 10 into 7. 7 can be written as 10 into 2 to the power 3 minus 1. What is 2 power 3? 8. 8 minus 1 is 7. 7 to 10, 70. That's it. So can you guess what's the next one? I think so. 10 into 15 is equal to 10 into, I think 15, how will we get? 3. Next time is 4. 4 means 2 power 4. What is 2 power 4? 16. 16 minus 1, 15. So that is the idea. So 1, 2, 3, 4. What about n equal to 0? What about n equal to 0? I think probably 2 to the power 0 minus 1. What is 2 power 0? 1. 1 minus 1, 0. That's why it is we get 0. So we can generalize it. That is very important. So when n equal to 0, it is 2 to the power 0 minus 1. N equal to 1, 2 power 1 minus 1. N equal to 2, 2 power 2 minus 2, 1. N equal to 3, 2 power 3 minus 1. N equal to 4, 2 power 4 minus 1. So in generally, what about x of n? Can you guess? So it is a 10 times 2 to the power n minus 1 for n equal to 0, 1, 2, 3, etc. etc. If you substitute n equal to 0, 1, 2, 3, you will get the same coefficient 0, 10, 30, 70, 150, etc. etc. So that is the idea behind this method. It is often called as long division method. We can expand the x of z as a proper power series, then collect the coefficients of z power minus n, that is z power minus 0, z power minus 1, z power minus 2, z power minus 3, z power minus 4. Then we can find the nth term, the general term, that is the required x of. That is the required x of. So got it? So this is the idea. Let us see the second example. The second example is example number 2. Find the z inverse of 2z into z square minus 1 by z square plus 1 to the whole square. Now first of all, we can rewrite this by z inverse of 2z power 3s minus 2z by the denominator we can expand. We get z power 4 plus 2z square plus 1. Now divide throughout by z to the power 4. What we'll get? We'll get this z inverse of z power 4. So 2 z power minus 1 minus 2 z power minus 3, because z by z power 4 means power 3. The denominator 1 plus z power 2 is there. So after cancelling some 2, we get 2 z power minus 2. Then what about the 1 by z power 4 plus z power minus 4? So this is the first step, very first step to rewrite in terms of power minus 1. Right? Minus 1, minus 2, minus 3, etc. But in here, unfortunately, what happened? We have seen that it is jumping the power 1. So here 1 means next to 3, here 2 means power 4. So what happened? Let us go for the long division method. Using the long division method, I am going to divide this 2 z power minus 1 minus 2 z power minus 3 by the term 1 plus 2 z power minus 2 plus z power minus 3. So as I told you that the first term, I want to make this cancellation. So when this becomes cancellation, this divided by the first term. So 2 z power minus 1. We get 2 z power minus 1 into 1, 2 z power minus 1. 2 z power minus 1 into 2, we get plus 4 z power minus 3. 2 into 2, that is 1, 2 z power minus 5. So let us change the sign, minus, minus, minus. This will get cancelled. So minus, minus, what is minus 6 z power minus 3, minus 2 z power minus 5. So this time minus 6 z power minus 3 comes here. This into 1, so minus 6 z power minus 3, minus 6 into plus 2 is minus 12 z power minus 5, minus 6 z to the power minus 7. So it is going like that one. Change the sign first, minus becomes plus, right? So cancel this one. So plus 12 minus 2, so plus 10 z power minus 5, plus 6 z to the power minus 7. Once again, what's the next term? The next term is 10 z power 5, so plus 10 z power minus 5. See that? Minus 1, minus 3, minus 5, minus 7. So it's jumping 1 by 1. So when I take this 10 z power minus 5, let's multiply this, we get 10 z to the power minus 5. 10 into 2 is 20. So 20 z to the power minus 7 and 10 z to the power minus 9. So it is going like that. Change the sign, minus, minus, minus. So this will get cancelled. Yes, plus and minus. And so minus 20 plus 6. So minus 14 z to the power minus 7, minus 10 z to the power minus 9. So this continue like that. If you go for the next term is minus 14 z to the power minus 7, isn't it? You go for the next term, the next one is minus 14 z to the power minus 7. So what I see that it comes only the odd powers. It comes only the odd powers. So this is very, very important, odd powers. So can we go for the same, the expansion of the x of z? What is sigma n equal to 0? Z to the power minus 0. X of 1, z to the power minus 1. X of 2, z to the power minus 2. X of 3, z to the power minus 3. plus x of 4 z power minus 4 plus etc up to infinity. But this time we have only the r powers only. So is equal to 0 first of all, no problem. It's 2 into z power minus 1 plus, I think there is no z, so it is 0 z power minus 2 minus 6 z power minus 3 plus 0 z power minus 4 plus 10 z power minus 5. So continue like that up to infinity. It's going up like that. Yeah, we are going to continue the same. But also if you get 3 to 4 times, it's well and good for us. Once if you are going to able to find the nth term, it is well and good. So from this what I conclude that when n equal to 0, x of 0, the coefficient of n equal to 0 is 0. For n equal to 1 it is 2, n equal to 2 0, n equal to 3 minus 6, n equal to 4 0, n equal to 5 10. So what is the idea? The idea is, I think so it is 2 6 10 coming like that, 2 6 10, 2 6 10. I think so it is somewhat only for the odd values, isn't it? So it is 2 6 10 etc etc, isn't it? So the same thing is for n equal to 1, this is n equal to 3, this is n equal to 5. I think so. What about nth term? N equal to 1 means 2 into 1 is 2, 2 into 3 is 6, 2 into 5 is 10. Yeah, next time is 7, 2 into 7 is 14. Yeah, right. I think so. I got the 14 here. Yes, right. Minus 14 actually. Minus 14. So here plus, here minus, here plus, here minus. So here plus, minus. So anyway, what's the nth term? The nth term is probably, I think x of n is equal to 2 to the power n. Yeah, I got 2 to the power n. 2, 6, 10, 4. But minus sign, plus sign get alternative. Minus sign, plus sign mixed up. It is not coming minus, it is comes under negative. Sometimes it comes positive. So what I suggest you that, can you think about the sin n pi by 2 value? What is sin n pi by 2? Sin n pi by 2 value. For n equal to 0, the value is 0. For n equal to 1, the value is pi by 2. That is pi by 2, the answer is 1. 1 is pi by 2 is 1. For n equal to 2, the answer is pi, sin pi is 0. For n equal to 3, the answer is 3 pi by 2, sin 3 pi by 2 is minus 1. So it will generate only the odd values of multiples of pi by 2. That too for n equal to 1 plus 1, n equal to 3 minus 1. For n equal to 4, what about this becomes? This becomes 4 means it is 2 pi, sin 2 pi 0. For n equal to 5, it becomes 5 pi by 2, it is plus 1. For n equal to 6, it is 0. N equal to 7, this becomes 7 pi by 2 is minus 1. So I think so, it is 1 means 1, 3 means minus 1, yeah, it is minus 6. N equal to 5 means plus 1 is correct. Then n equal to 7 means minus 1. So this is exactly looks like 2n into sin n pi by 2 for n equal to 0, 1, 2, etc. up to infinity. This is the required, the is the inverse of x of n. So to get the nth term, somewhat is very tough unless there is if you don't know the basic concepts. Once I repeat this, putting n equal to 0, 2 power 0 is 1, but sin 0 0. So there is no term x of 0 0. N equal to 1, I found 2. Yeah, 2 power 1 is 2, sin pi by 2 is 1. So 2 into 1 is 2. Putting n equal to 2, sin 2 into pi by 2, sin pi 0. So there is no x of 2 when x equal to n equal to 2. N equal to 3, we get 3 pi by 2 is minus 1, 2 cube is 6, 6 into minus 1 is minus 6. That's it. So this is the idea to determine the inverse Z transform by using the long division method. Is often called as the power series method. So the technique is different. The technique is completely different because it has a more than one technique to determine the Z inverse. So please kindly go to watch our lecture series. There are many techniques are there. Please go and watch the conversion theorem and the power series method, residual method, as well as the method of partial fraction. Please kindly watch our YouTube channel so that you can know the different techniques to get the inverse Z transform. Thank you so much. Subscribe our YouTube channel. If you are not supposed to do that, please kindly press the bell button so that you can easily notified whenever the new lectures, new videos can be uploaded in our YouTube channel, ADC Max. Thank you so much for watching our YouTube channel. Thank you. Take care. Bye.